Web crawling is the first step in how search engines discover content online. Search engines use automated programs called web crawlers, also known as spiders or bots, to explore the web. Web crawlers systematically browse the internet by following links from page to page, much like a person clicking through websites. They move from one page to another by following links, exploring new content, and pathways. Crawlers use sophisticated algorithms to determine which sites to visit, how often, and how many pages to index from each site. They maintain a priority queue, deciding which pages to crawl next, based on various factors like importance and freshness. Web crawling is a continuous process. Crawlers continuously explore the web, finding new pages and revisiting existing ones to check for updates. This ongoing cycle ensures search engines maintain up-to-date information about the constantly changing web. Web crawlers form the foundation of search engines, continuously exploring the internet to discover and update content for users to search. After web crawlers collect data from websites, search engines need to organize this vast information for efficient retrieval. This process, called indexing, involves processing and storing information in massive databases. During indexing, search engines analyze different aspects of each page: content, metadata, and structure. This massive amount of information is stored in sophisticated data structures called indexes. The index organizes information in a way that allows for extremely fast retrieval when users perform searches. When a user performs a search, the search engine can quickly scan the index to find relevant results. This indexing process is what enables search engines to search billions of web pages and return results in a fraction of a second. Ranking algorithms determine which pages are most relevant to a user's search query. Search engines use complex algorithms that consider hundreds of factors to determine which pages are most relevant. These include keyword relevance, page authority, content quality, and contextual factors like the user's location. Google's PageRank algorithm revolutionized search by evaluating the quality and quantity of links to a page as a measure of its importance. Pages with more high-quality inbound links receive higher rankings. Let's see how this works. Modern ranking systems have evolved from basic algorithms to sophisticated machine learning models. These systems continuously improve by learning from user behavior and engagement patterns. When users click on certain results, spend time on pages, or quickly return to search results, the algorithms learn which pages were more relevant. In summary, ranking algorithms are complex systems that combine hundreds of signals to determine the most relevant results for each search query. These systems are constantly evolving, with machine learning playing an increasingly important role in delivering the most useful search results. When you type a query into a search engine, it doesn't just match your exact words. Modern search engines use natural language processing to understand what you're actually looking for. The search engine breaks down your query into meaningful components and analyzes them through several NLP processes. Search engines can recognize and correct misspellings in user queries. This helps users find what they're looking for, even when they make typing errors. Search engines use semantic understanding to recognize synonyms and interpret the true meaning behind ambiguous searches. Search engines also personalize results based on your search history, location, and preferences to provide more relevant information. The semantic understanding of search engines has evolved dramatically with advances in artificial intelligence and machine learning. As query processing continues to evolve, search engines become better at understanding exactly what users are looking for, even when queries are imprecise or conversational. Search engine results pages, or SERPs, are what you see after entering a query in a search engine. They form the digital interface between users and the vast information organized by search engines. A basic SERP contains various elements organized to best match your search intent. Modern SERPs have evolved far beyond simple blue links. Organic listings, traditional ranked web page results, rich snippets, enhanced listings with additional information, featured snippets, direct answers displayed at the top, knowledge panels, information boxes about entities, image and video results, visual content related to the query, maps, location information for local searches, advertisements, paid placements marked as ads. SERPs are not one size fits all. They adapt based on the type of query and perceived user intent. For an informational query like "What is quantum computing?", the SERP prominently displays featured snippet. For a local query like "Pizza restaurants near me", the SERP prominently displays map pack. For a commercial query like "Best smartphone 2023", the SERP prominently displays shopping results. Search engine results pages continue to evolve, becoming more responsive to different types of queries. SERPs continuously evolve to better serve user intent. Visual elements increasingly important. More direct answers without clicking through. Personalization shapes individual experiences. Search engines continuously learn from how users interact with search results. They track which results users click on, how long they stay on a page, and whether they return to the search results. This user behavior creates a feedback loop that helps search engines refine their algorithms and improve future search results. If users frequently skip the first result and click on the second, the search engine might adjust its ranking accordingly. This creates a continuous improvement cycle where the system becomes more accurate over time based on millions of daily interactions. Through this process, search engines adapt to changing user needs and preferences, continuously improving search quality through the wisdom of the crowd. Search engine optimization, or SEO, is the practice of optimizing websites to rank higher in search results. When website owners implement good SEO practices, their sites climb higher in search results, gaining more visibility and traffic. Website owners use several key techniques to improve their search rankings. Keyword optimization involves strategically placing relevant search terms throughout website content and metadata. Creating high-quality, informative content that engages users is perhaps the most important SEO strategy. Building backlinks, where other reputable websites link to your content, signals to search engines that your site is trustworthy and authoritative. Search engines constantly update their algorithms to reward high-quality, relevant content while penalizing manipulative tactics. This creates an ecosystem where content creators strive to create valuable resources that align with what users are searching for. Theoretically, this continuous improvement cycle improves the overall quality of information available on the web. The future of search engines is being shaped by rapid technological advancements. Artificial intelligence and machine learning are revolutionizing how search engines understand and process information. The way we interact with search engines is evolving beyond typing. Voice search, visual search, and augmented reality are creating new ways to find information. Technologies like BERT and GPT are dramatically improving natural language understanding, making search more conversational and intuitive. Future search engines may anticipate our needs before we even search, providing information based on our context, habits, and preferences. As the internet grows more complex, search engines will continue to adapt, helping users navigate an ever-expanding digital world with more personalized, contextual, and intuitive tools.